In this lesson, we'll do a brief introduction to a really important system in the brain that we're going to call the working memory system, or sometimes called working storage. It's a system that operates over the course of a few seconds, and it's a temporary storage system for information. That information may be accessed from long-term memory, but it could be whatever it is we're currently processing, what we're seeing, hearing, etc. In addition, you might be maintaining goals in the working memory system. Whatever information is in working memory can be manipulated, like when you're doing mental math. It's also related to the attention systems so that we can sustain our activity in pursuit of a goal. Now we're going to make a comparison with computers. While brains and computers have many differences, there are many similarities as well, and the differences are instructive. Computers have what we call a hard drive, and this is a long-term memory system. However, it's relatively a slow access system, so the retrieval of information from the hard drive is relatively slow, but it has a large capacity, large storage capacity. A lot of information could be stored on the hard drive. Computers also have another kind of memory system called the RAM, and this is more like a short-term memory system. We're going to compare it to the working memory system. And the information in the RAM is quickly accessed, so the central processor of the computer can more quickly access the information that is stored in the RAM. However, it's got a much smaller capacity. Not as much information can be stored here. So we've got these two memory systems in a computer. The small capacity but fast access memory system, the large capacity but slower access hard drive, long-term storage. Now, to give an example of how the memory systems are used in a computer, let's say I'm doing some video editing. Well, when I open up the video editing software, the program is going to be running using the RAM system here, but my videos are stored on the hard drive. So as I do video editing, the systems are going to have to communicate. The hard drive has to be accessed. The videos that are stored here have to be loaded up into the software, into the program that is running on the RAM. And by the way, if I open up 5 other programs, that's going to be utilizing more and more of the RAM memory, and that can be a problem because this is a limited capacity memory system. We can then think of the goal of an education then is to strongly store information into long-term memory for quick and reliable retrieval, meaning loaded up into the working memory system for use in the current task. So to be educated means that we've got a lot of data written to our hard drive that is accessible by the short-term memory system so that we can make whatever computations we need to guide our behavior. Now, in earlier lessons, we learned a little bit about the functional organization of the cerebral cortex. And we noticed up here in the frontal lobe these words thought and forethought. We're going to associate those with the working memory system. As it turns out, the working memory system in the brain also has regions in the posterior part of the brain that seem to be active during tasks that involve working memory. We're going to focus though on the frontal regions here, and so we're going to put a box in the frontal cortex here, and this will be our icon for the working memory system. And again, it's a short-term information storage and processing system. It would be the RAM in the computer. And notice that what's in the working memory system we will write inside the box, and right now I just have what you're thinking about. So whatever you're currently sort of conscious of, this will be the contents of our working memory system, and we'll say more about that in a moment. We will note at this point, however, that the working memory system in human brains seems to be a limited capacity system, just like the RAM in the computer. We just can't think about too many things at once. We quickly run up against a limitation of the working memory capacity. In a previous lesson, we also learned that down here in the temporal lobe, the word memory was written down here. And it is true, there's lots of evidence that the temporal cortex, especially the medial temporal cortex, seems to play a critical role in the long-term memory system. But scientists think that long-term memories are more widely spread across the cortex, but we'll use the temporal cortex down here to be our sort of location for long-term memories. And so we're going to put little hard drives down here in the temporal cortex to indicate long-term memory. So brains have the equivalent of a slower, larger capacity memory system called long-term memory. And the two kinds of memory, the working memory system and the long-term memory system, interact. so that information in working memory can be written to the long-term memory, and information in long-term memory can be accessed and loaded up into working memory. So let's take the first of those processes. So here in the idea here is whatever's in working memory has the potential to be stored or written to the long-term memory system. And again, we're down here sort of in the temporal cortex, and there's a really critical structure called the hippocampus. This structure lies underneath the temporal cortex, and it is very important in memory processing. So we're going to just identify the entire medial temporal lobe as a critical memory structure. But the idea is whatever's in working memory can be, in a sense, processed by this memory system and written to the long-term memory system. So memories, we're going to argue, are stored in the cerebral cortex. And like a computer, information in working memory can be stored, written to the long-term memory system. But in addition, the flip side of that is that information in the long-term storage system can be retrieved as well. And so we can access that information in long-term memory. And why would we want to access that? Because we might have learned something useful in the past that has applications to the current moment. So we want to be able to retrieve information from the long-term memory system. When we do that retrieval, we're sort of loading up the information into the working memory system. So what we have then is that working memory stores information from other brain areas for a short time so that the information can be manipulated, used for long-term memory retrieval, guide attention, or sustain a goal to guide behavior. So the information in working memory is coming from either other areas of the brain that are processing what we're seeing and hearing and so on, or from our long-term memory systems. So let's look more closely as to what are possible contents for the working memory system. So our experience of our own working memory includes whatever it is that we're currently perceiving or thinking about. So if we're perceiving things, then our sensory systems in the brain are sending information to the working memory system, and we're having a conscious experience of what we're seeing, what we're hearing, etc. So many of our perceptions originate from the external world. Our sensory systems, the vision, the hearing, touch, taste, smell, create a conscious experience about what is happening in the world. You'll recall that the posterior part of the cortex is the location of some of our principal sensory systems and perceptual systems. So hearing, vision in the back, touch up here. So we said that the posterior part of the brain is sort of answering the question, what is happening? Well, these regions of the brain are going to be sending the results of their computations to the working memory system, and we will have a conscious experience in a sense of what it is we're currently perceiving. Other contents of working memory are generated internally by the brain itself. These include verbal thoughts and visual images. Let's first consider verbal thoughts. Now, what is it to have a verbal thought? The idea here is we're sort of thinking, and we can do this quietly. We're not saying anything, but many people report sort of hearing a voice in their mind, and that voice is sort of just saying the thought that you're having. So a verbal thought can occur with no external stimulation from the outside world. We can just sit quietly in a room with no sound. We can close our eyes and we can think. Now, in the previous lessons, we learned again about the functional organization of the cortex, and we noted that there was a speech region up here in the frontal cortex. It seems to be activated when we are speaking, processing speech, and so on. And there's a posterior region that seems to be important for understanding written and spoken language. So we're going to call these language areas of the brain. So the idea then is when we're having a verbal thought, it's the language areas that are getting activated and providing the contents to our working memory system. So our thought is verbal because it's the language areas that are the ones providing the contents of the thought. Now, we can also have other kinds of auditory experiences in our working memory. For example, you might be going through the day and you just can't get that song out of your head. Well, and the temporal cortex is where the hearing part of the brain resides. And so we may have the stored memory of a song, the melody of a song stored there, and if it gets activated and reactivated consistently, we may have the experience then of a song that we can't get out of our mind. So the auditory cortex then would be providing the content of the working memory to the working memory system, and that content happens to be the melody of a song. For visual imagery, the idea is it's the visual system that is providing the input, right, the content for the working memory system. You'll recall the visual system back here in the posterior part of the brain, and it runs all the way down through the temporal cortex here. So we're just kind of saying that when the visual system becomes activated and provides inputs to the working memory system, then we're having a visual image. This can occur with our eyes closed. So the difference between perception and imagination is that if my eyes are open and I'm looking at the pizza, I'm perceiving the pizza. But if I close my eyes, I can imagine what the pizza looks like. That's imagery. And the idea is the visual systems are being activated during that sequence, that imagination process, and providing the input to the working memory system. Interestingly, there is significant individual variation in the vividness of mental images, and we'll explore that later. So what we have then is frontal cortex systems along with parietal cortex systems providing a temporary workspace for information provided by other parts of the brain. It could be the visual system providing visual inputs, could be the auditory system, auditory inputs, the language regions, etc. Information in the workspace can then be broadcast back to other brain regions to guide further processing. For instance, a verbal thought in working memory can trigger the next verbal thought by activating language areas. So there's a two-way communication. The language areas can provide the input to working memory, but whatever's in working memory can reactivate those same language areas to provide a sequence of thoughts, for example. Or a verbal thought can trigger the retrieval of a long-term memory. So whatever's in working memory can trigger the retrieval of a long-term memory, and then that gets loaded up into working memory. So we have the experience of remembering something. So we've got this dynamic interaction between the working memory system and other parts of the brain. It is a two-way street, that other parts of the brain can provide inputs to the working memory system, but the working memory system can then reactivate those same areas of the brain. And we'll focus on the long-term memory system, the interaction between working memory and long-term, in the next part.